Hi everyone. Now we are going to be discuss on the topic distributed DBMS architectures from the subject distributed database systems. Here the DBMS is very important with respect to the query processing and which is required for distributed database environment. In distributed database environment, both the data and the software required to process the query got distributed across physical locations. So, what sort of DBM architecture required in which context it is to be known? Though the DBMS software, which is to be identified for the distributed environment, we have different DBMS architectures to be explored and to identify the correct one to your context, where your requirement is perfectly identified and the suitable DBMS architecture is also picked by you in the context. So here, first one, we will think about the client server architecture, where the client server is defined with the terms like a client is the one which is preparing the query or request and expecting the response from the server. In this illustration, we will see top layer where operating system equipped with the user interface, application programs, client DBMS, and communication software. This is the environment. It is allowing the user to prepare the query and to submit to through SQL query submission, and finally getting the response through the channel called result relation. Okay, once query submitted, who are here for us to provide the suitable results? So that is also available with the name called operating. Comprises communication software, semantic data controller, query optimizer, transaction manager, recovery manager, runtime support processor, in order to access the real database and to provide the proper data for the end user. So here we can have advantages of client server architecture with centralized data management and control, where data integrity, unified security, and streamlined backups are available, with optimized resource utilization, where you are going to be save your resources properly. You are able to run the query with the minimum cost required here with the exercise you have done. Then the enhanced scalability. It is the process of scaling the independent. It is the expanding the resources horizontally. It is also trying to improve the network efficiency with the data localization and the process localization, which are very important, which are available through the proposed client server mechanism. And one more advantage from the client server architecture is that it is simplified maintenance and deployment. So here we have a central update and we have the modular development, which is possible with this architecture, where database schema modifications, software patches, and the API updates are deployed once on the server, and it is instantly reflecting across all the clients. So at one place, giving access to the different clients scattered, and all these clients are able to access this particular facility and to get the response to their submitted queries. In modular development also, the interface designers can revamp the client application without touching the underlying database structure, as long as the communication APIs remain unchanged. So here data independence, physical independence and logical independence is also well supported. In this, the client server architecture, where client is on the top role, application server in the middle layer, and database server in the bottom layer. Here database server plays the important role in this client server architecture in order to provide the facility required. So database server is the dedicated computer system aspects of hardware context, running a DBMS software to provide the data storage, data retrieval, and manipulating the data required as per the query submission to other programs and the computers. So it is doing the storage, retrieving the data required, and manipulating the data as per query execution. Then, equipped with the application server, this application server in a distributed database acts as the intermediate broker that executes the business logic and coordinates how user request with the data from multiple physically separate database nodes. So it is the intermediate between client and database server. Database server is the component sits between application server and the real database. In distributed database servers, we have different clients sitting at different locations, expecting the service from the real database with the help of application servers and database servers. All of them are connected over the network. Here we have the clients layer, we have the application server layer, we have the database servers layer, and this is the real databases are connected over a network. This network is connecting the different components scattered across the world. So here in this distributed database server environment, we have three layers. One is presentation tier, second application tier, and third one data tier. So in presentation tier is given for client. It shows the boxes labeled as clients at the very top. They are the people expecting services from the infrastructure. The functionality of that is the user interface layer, that end user interact with the system, maybe web browser, mobile app, or a desktop application user interface to get the required response. Role, it captures user inputs, it displays the data and sends network requests downward. It contains zero business or storage logic. This particular layer able to receive the request from the client, forward it to the bottom layers. Then application tier is also called application server. It shows the central block labeled as application server sitting between two distinct networks, which are able to take the request from the client, and it is submitting to the query execution area. After query execution, it receives the response from, and it is preparing the response which is to be submitted to the client finally. It functions as is a brain of the computer. It is the middle layer of the system and running the code written in the different languages like Java, Python, Node.js, C Sharp, etc. It also processes the business logic. It enforces validation rules to be followed. It performs the calculation and decides exactly how data must be manipulated before storing or displaying it. So It works on executing the query through which the proper response to be submitted to the end user. Then data tier, also called database server and storage. So it shows the bottom block labeled database server. It connected to a physical cylindrical disk. It is a layer that interacts with the real world data and retrieving the data which is required by the end user. It the functionality of this particular layer is data storage and management. Okay. Then the role of that particular thing is the database server executes the raw queries taken from the end user, the client. It manages the data consistency. So all of them are looking the same data. It handles the file indexes to know what type of data is available at a particular location. And after execution, it is to be perform read write physically to the persistent storage disks. In this distributed database server, it is the one that manages the data spread across multiple physical or virtual nodes connected over a network. But it is giving the illusion to the end user that as a single logical database. Here core architectural concepts are also defined here. They are the data partitioning, data replication. This data partitioning talks you on how rows or tables are split into smaller pieces across distinct servers, and they are ready to provide the response to the end users. For example, a user data can be split horizontally, horizontal partitioning, by geographic region or user ID. So here data splitting happens based on the physical region or based on the user IDs. First 1 to 50 user IDs at location 1, 51 to 75 location 2, 75 to 100 location 3 are based on geographic region. So based on the Axis Bank customers belongs to Telangana. Axis Bank customers belongs to Karnataka. Bank customers related to Andhra Pradesh. Like this, you can do horizontal splitting. Data replication states about the copies of data are mirrored across multiple servers. Full replication stores the entire dataset on every node, while partial replication copies only high demand subsets to local nodes. So based on the need, they will conduct the replication instead of fully replicated. Here there are core server types aspects happens with the distributed client server environment, where the database type is the first column, key characteristics is second column, and examples for that is third column. In distributed database type, SQL is a NoSQL environment. Characteristics are the native horizontal scaling while keeping the strict ACID transactions and relational tables as followed, in which atomicity, consistency, isolation, durability, it is to be fully followed. In this environment, the cockroach DB and TIDB, Yugabyte DB are the examples for this aspect for distributed SQL. Second, NoSQL distributed. Here, the schemeless structures optimizing for high volume, rapid writes, and eventual consistency is the theme of this particular database. The MongoDB, Apache Cassandra, DynamoDB comes under this aspect. Now, cloud native global with the fully managed database as a service natively scaling across the global regions. Google Cloud Spanner, Amazon Aurora DSQL comes under this aspect. Comes to this peer-to-peer database type, every node handles both application storage and query processing with no master server. All the nodes are equally designated, equally equipped, and they are able to communicate easily with a common language. And there is no hierarchy here. The blockchain networks at seed is comes under this particular category. What are the system trade-offs between distributed clients of architecture? It is the CAP theorem. What is CAP stands for? C stands for consistency, A stands for availability, and P stands for partition tolerance. So here, the CAP theorem dictates that the system can only guarantee 2 out of 3 properties during the network partition here. So consistency state every read across all locations returns the absolute latest write. That's the consistency. Every node can see latest write. Availability. Every non-failing node returns a non-error response without a guarantee it contains the latest write. So it is responding with the non-error data. Then partition tolerance. The overall system continues to operate though the network drops or communication breaks between nodes. Ability to continue the system even in the abnormal situation. That is the trade-off with the CAP theorem. What are advantages and operational challenges we can consider here? The scalability, the low latency, fault tolerance, complexity, and security. These are the features which we can claim as the strength of or advantages of this particular aspect. Then comes to peer-to-peer component architecture is mainly illustrated with the user, the top layer, user process in the middle layer, and data processor in the bottom layer. This is directly connected to this real-time database. The user processor is also the global client layer. It is having user interface, then data controller. In user interface handler, the functionality is to interact directly with the end user by accepting request and returning final database response. This is the layer ready to take the request from the user, forwarding it to the respective layer to run the query, receive the response, and submit it to the end user. In the schema connection, it requests a external schema which defines how different applications or users see the data. The complete complexity and difficulty is mapped from the end user. Then data controller. The data controller, it checks user access controls, who are allowed for what purpose, semantic integrity constraints, and verifies authorization, what they can do, for what purpose they are allowed. In schema connection, it's a global conceptual schema which represents the unified logical view of the entire distributed data set. So the user interface handler, the data controller comes under the first user processor layer. Then the global query optimizer, it is looking for executing the query with the minimum cost. That is the main functionality of that. Then distributed execution monitor. It acts as a coordinator. It translates the global execution plan into specific commands. It ships them out to target nodes across the network and tracks their execution progress and looking for successful execution to return to the user. Then second layer is data processor, the local server layer. It is also having local query processor, local recovery manager, runtime support processor. So in this local query processor, it is looking for, receives the localized fragment of query and compiles it into a local data access commands. This is the brain of the system here. It receives the query from, it thinks how to execute this query, how to provide the best response to the end user. Schema connection also, the local conceptual schema it is looking at. It describes the logical data structure that physically residing only on this specific node rather than external conceptual schema. Here, local recovery manager is also there. It's a program that maintains database transaction properties, atomicity, consistency, isolation, durability, with the safety as the objective. It ensures that the local modifications are committed completely or rolled back cleanly during the crash. If it is completely successfully executed, the data is going to be stored for a long time with the durability, and accessibility is given to that to access the most recent updated data. If it is failed to complete the execution successfully, we to do rollback. Okay. The storage connection talks you on. It's a constantly write state update to the system log. So whatever the updates happens to the query execution, it is to be saved to the log session. The runtime support processor, it is for executing the compiled low-level commands against the storage engine. It manages the operating system memory buffers and read writes the physical bytes. So this is the one, it's active in the environment to perform the things which are assigned to it with respect to the processing. Then schema connection, it talks about mapping the commands to the local internal schema that describes how data blocks are physically indexed and laid out on the disk storage. Sys with the MDBS, multiple database system components and execution, where user layer, MDBS layer and component data base management systems are available, and which are to deal with this particular context. So here core components listed: user 1 MDBS layer, it's the middle layer, component DBMS, which are connected to the storage cylinders. In this user context, the end user, the client application or global admin interacting with the system to get the response, to get the required data from the infrastructure provided. MDBS layer, the central integration that acts as a translator. It receives the global queries from the user, decompose them into subqueries for the individual databases, run them with the support, and merges the retrieved data into a single response. So in this distributed DBMS, we can have different types of DBMS. So one is in MySQL, second one is NoSQL. Then how these two are able to communicate? It is required. MDBS layer is required to act as the translator. Then component DBMS, this is the independent localized database management system, MySQL, Oracle, PostgreSQL, that operate autonomously. They are unaware of the other database in the network. Simply, they will see their work given to that. They will work on the query execution required in their local node. These are able to communicate with the storage cylinders. These are storage cylinders. The workflow And data flow involved here is first user request. The user sends a single global query downwards to the MDBS layer without needing to know where the data physically resides. User may submit query at the location 1, but in order to run this query, the data may be available at location 5. But user thought that there is a single storage, there is a single software system available to which I am able to connect, where I am able to run the query, I am able to retrieve the data from. But in reality, the data and the software required to run this query is scattered across the world, and they are providing services as a single system. Then query distribution in this context has the MDBS layer communicates bidirectionally with the various component DBMS nodes, routing the appropriate subqueries to each system. It is handling with the different DBMS, connecting to different nodes. Then local processing. Each component DBMS fetches data from its own physical storage cylinder and sends the result back to the MDBS layer. So this is the one which is able to connect with the database, getting the data required and submitting it to the middle layer called MDBS layer. The system response there, the MDBS layer cleans, aggregate and formats the collected data before sending the final unified response to the end user who are sitting at the top level. So user request submitted to query distribution is connecting with the local processing and is having the relationship with the system response. In the architecture defined, multiple DBMS architectures are available, like client server architecture, peer-to-peer architecture, and multi or different layered architecture. Mediator wrapper architecture, where user interaction is there and intermediate layer is there, wrapper is there, and DBMS connected to different databases, where the core layers like user layer, mediator layer, wrapper layer, and data layer. The core layers named user layer, mediator layer, wrapper layer, and data layer are performing different functions. User layer is entry point of application from which they are requesting the data. Mediator layer looking for the central intelligence is to receive the request, forwarding it to the, then receiving the response in the receiving order and submitting the result to the end user. The wrapper layer, it's a translation interface. It's going to be connect with the different components and making it a smooth environment to run the query successfully. Then data layer, it's a physical database layer. Now we will see how component will work here. Mediator, they process global user queries. First function. Second function, they break down complex request. Then they combine the separate data results before submitting to the end user. They handle system semantic conflicts. They have difference. Then the wrappers will do the mask data source differences. So here we'll have the data differently in different locations. The data schema is different. The software they are using is different. So though everything is different, we have the option here to mask all these differences and to provide an environment where query execution is smoother by make use of these wrappers. They're also translating the queries for DBMS, and they're able to convert data formats of Word is to have a commonality in the execution. Then data flow. In data flow, requests initiated by the users from the top layer, they send the queries to the mediators. Mediators talk to specific wrappers, routing to the nodes where the query execution is possible. The translation is the one done by the wrappers that query the underlying DBMSs, and they are capable of fetching the data from the storage space, and they are submitting the data to the end user finally. So first request to be received, identify the location to whom it is to be submitted, then query execution is possible, from that data to be extracted and to be returned to the end user successfully. These are the important layered involved in order to prepare distributed DBMS architecture. There are also on rental basis architectures, they are called cloud computing, and rental basis architectures are available in the form of infrastructure as a service, platform as a service, software as a service, and database as a service. Based on user request, you can approach the service provider and use the opportunity and the resources available for you, and finally you to paid the bill to the service provider. In this simplified cloud architecture, users are sitting at different locations. They are able to make use of services available from the service providers, and there is a intermediate layer. This layer is called middle layer, which is able to connect the users from different places are requesting different services available at different locations. Over the internet, this communication is possible. So, client server, peer-to-peer structure, and multiple DBMS layered architectures that you can see. In recent days, many people are approaching the cloud architectures where you don't need to have infrastructure with you, which is required for you. You just connect with the service provider, and you submit your request, and you are able to get the response in forms of infrastructure what you want, the platform what you want, the software what you want, and what the data you want on a rental basis. Thank you for your attention.